Okay, so can you do this problem? And if you cannot, then you're going to have a difficult time passing Algebra 2. But no need to panic. We don't need to get into this state and be like, oh my goodness, I'm going to fail Algebra 2. No, that doesn't have to be the case at all. Okay, but we do need to fix this real quick. If you're at the Algebra 2 level, college algebra level, anything beyond Algebra 1, then you should, definitely be able to, at a minimum, identify what's going on here, and obviously, even better, be able to actually do this problem. Okay, so what is the topic that we're going to be talking about here? Okay, well, let me just ask you that. Do you even know what we're talking about? Well, hopefully, most of you out there is saying, I think it has to do with this imaginary little I thing, and you would be on the right track. The topic here is really complex numbers, okay? Complex numbers. And complex numbers is a pretty big topic in and of itself. And we're trying to do something here. We're trying to multiply two complex numbers. That's really the problem. And this is something that you probably were introduced to at in Algebra 1, at least the concept of complex numbers. But in Algebra 2, you definitely need to know how to work with complex numbers, and this is not that difficult. So if you are, upset that you didn't know what this is, no need to panic. We'll quickly review this, and by the time we finish with this video, you will know exactly how to do this problem. Okay, but before we get going, let me quickly introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher, and over many years, I've constructed what I like to believe is one of the best online math help programs there is. Of course, I'll let you be the judge of that if you're interested. You can find a link to my math help program in the description of this video. But if you need to take a full online math course, I can help you. I have several courses. Or if you need assistance in a course that you're taking, I can help you. Okay, I have full lessons, and I teach you how to solve the most common problems you're going to encounter as a middle school, high school, and college, basic entry level college level mathematics. So I literally solve thousands of problems. So if you're interested, you can find my math help program, follow the link in the description of this video. Now, if you are a student, one thing I must stress to you is the importance of note taking. Okay, my golden rule of math is, I've just seen it through decades of teaching math, is those students who take the best math notes almost always have the best math grades. And the reverse is true. Okay, some of you, unfortunately, might say, I don't need to take math notes. It's not that important. What's more important is for me to check out my cell phone and talk to my best buddy in my class. And of course, that's the way I was. And there was no cell phones back in my day. But if there was, I'm sure I would be on it, not paying attention to the teacher, taking good math notes. Okay, you got to take great math notes. It's an absolute 100% essential skill that you must master. Okay, if you don't take note taking seriously, you will pay the price, unfortunately. Okay, so take a look at your notes. If you haven't been, doing the right things, then start improving. There's always a room for improvement. But if you start improving your math notes, your math grade, everything will start to follow. But in the meantime, you need something to study from. So I actually offer excellent detailed comprehensive math notes. Those would include pre-algebra, algebra 1, geometry, algebra 2, and trigonometry. So if you want to check those out, you can find them by following the links in the description of this video. All right, so complex numbers, that's a topic. And let's just do a quick rehash of why complex numbers are important. This is going to be a very, very brief rehash because this is a big topic, okay? So in algebra 1, let's say, and previous, okay, to all your elementary schools, and we'll put algebra 2 over here because that's kind of what we're talking about. We were dealing with what kind of numbers? Well, primarily you're dealing with the number line, right? We have like 1 here, 2 here, -1, -2. We have like pi, square root of 2, -3, 2/3. What kind of numbers are these? Yes, you guessed it. This is the real number system, okay? Real number system. And that's what we've been using, and we still use it, obviously, in all mathematics, but exclusively so in Algebra 1, and prior to that, you've been using these type of numbers, the real number system. But somewhere along the line, you encountered the need to learn another number system. So let's just quickly see where that kind of happened. So let's take these two equations here, x squared equals 16 and x squared equals -16. So this equation, x squared equals 16, I'm saying what number times itself is positive 16? So the way we solve that, we just take the square root of both sides and we get x is equal to plus and minus 4. Because a positive 4 times a positive 4 is positive 16, and negative 4 times negative 4 is also a positive 16. So what number times itself is positive 16? Well, positive 4 and negative 4. So this is a basic quadratic equation, and there's always two solutions to our basic, to all quadratic equations, and here they are, positive 4 and a negative 4. Now, let's take a look at this quadratic equation, x squared equals negative 16. So if I gave this question, I would say 50% of the students would be like, oh, x is equal to negative 4, right? And then I would have to give you a big smiley face, take a bunch of points off, and then there'd be, crying and whatnot. And I'm like, no, don't need to stress. What we need to do is learn, say, a different number system here. Because look, if you're saying x is equal to negative 4, what you're telling me is negative 4 times negative 4 is negative 16. No, that's positive 16. So what number times itself is going to get me back to a negative 16? Well, we're like, yeah, that's a good question. So let's go ahead and take the square root of both sides, okay, like we did over here, and go to your calculator and take the square root of negative 16. Okay, your calculator might start to smoke or shake or say something to you. It might come out with a little error message or something like, I don't understand, because your calculator primarily is operating with real numbers. Now, if you have a more sophisticated scientific calculator, you could plug this in and it will give you the right answer. But for the most part, any basic calculator, even like your cell phone, it's not going to understand it. It's going to be like, I don't understand this question. I don't understand how to get the answer. That's because, it's thinking in terms of only the real numbers. We need another number system. We cannot solve this equation, x squared equals negative 16, with these numbers over here. We need more numbers, okay? We have to go get ourselves another number system, and that would be the complex number system, all right? So it's a very, very important step up in your understanding of mathematics, because the complex number system is over here. The real number system actually lives inside the complex number system. You got to understand this. Now, if you're saying, well, this is a lot of information, I don't remember all of this, I just want to know how to do the problems. If you're thinking in those terms, like just show me how to do the problems, guess what? You're not going to be able to really master and comprehend this material. And then math is going to be a struggle, because you're not just going to be able to memorize and just do problems. You have to understand, okay, and put all the pieces of the puzzle together, okay? Now, complex numbers, all right, it's a big topic. I'm not going to go into all of complex numbers, but with complex numbers, they're in the form of a plus bi. There's an imaginary component and a real number component. Now, with any number, all right, you can do various operations with complex numbers. We can add them, we can subtract them, we can multiply them, and there's kind of a basic concept of division, and there's these things called complex conjugates, etc. We can graph these things, but primarily when we're solving more sophisticated equations, beyond Algebra 1, okay, into Algebra 2 and college algebra, pre-calculus, etc., we need to really understand complex numbers, okay? So that's, my sales pitch to you, why complex numbers are important. So what are we trying to do right here? Well, we're trying to multiply two complex numbers. You have to know how to do this, do these type of basic problems. Now, if you look at this, this looks very much like doing a problem like, x plus 3 times x plus 5. If you are thinking, this looks like an algebra binomial problem, like this times this. That's exactly right. That's good, okay? This is exactly how we want to start this problem. We just use that FOIL method, okay? First, outer, inner, last, okay? Then we're going to go ahead and combine like terms, more or less. So let's go ahead and do this problem. All right, so again, we're going to treat this just like a binomial. So we're going to go 3 times 2, that is 6. And we'll go 3 times this negative 4i, that is going to be negative 12i. We'll put that right there. and then 5i times 2, that is a 10i, and then we get 5i times this negative 4i. All right, so let's just be careful here. 5i times a negative 4i. So what's that going to be? Well, we're going to multiply the numbers, 5 and 4, so we're going to get 20, and then an I times an I is an I squared, and we got this negative sign. So that's negative 20i squared, right? So let's just make sure we understand this. 3 times 2 is 6. 3 times this negative 4i, negative 12i, 5i times positive 2, 10i, and then 5i times a negative 4i is negative 20i squared. Okay, so now we have to combine like terms. And here we have a number 6. It's by itself, so we'll just keep this here. And here, these guys are exactly the same. They both have an I, so a negative 12i plus a 10i would be a negative 2i. Okay, so that's good. So now we just have to figure out what to do with this thing, negative 20i squared. All right, so the first thing we need to understand to be able to simplify this is what is the definition of I, okay? So I equals the square root of negative 1. All right, again, I don't want to turn this into a complete lesson on complex numbers, but hopefully you understand this, right? So this imaginary part is equal to square root of negative 1. So I squared would be what? Well, we just square both sides, and this square root goes away, right? So in other words, here, if I is equal to the square root of negative 1, if I square this and I square this, I get I squared is equal to negative 1. Okay, so I squared is equal to negative 1. So this right here is negative 1. Okay, so now I can simplify this because this is really negative 20 times negative 1. So negative 20 times negative 1 is a positive 20. All right, so this is plus positive 20. So that's what this really is right here. Okay, plus positive 20. Now I could combine like terms. I have 6 and 20, and that's going to be 26 minus 2i. Okay, remember we want to write complex numbers in terms of the form a plus bi, our real number first, so that's 26, and then our imaginary part, in this case, that's 2i over here, and that is the answer. Okay, we have something called closure in mathematics, meaning that if we are multiplying two numbers, a complex number times a complex number, the answer itself will be a complex number. Okay, and so we want to write that as such, right? So 26 minus 2i, and that is the answer. Now, if you were able to do this problem, I would say that that is pretty awesome. I would definitely give you an A plus and 1000%. So that, I know that makes your day. But again, you don't want to get overly confident because this is a fairly easy problem, right? There's a lot to know about complex numbers, but this is a good start. But the most important thing is to know why we need them. Okay, I mean that's the whole essence of mathematics. It's not able to do these processes. This is like following a recipe. It's like, oh yeah, I can do this problem, but what does this mean, and why do we even have to do this? Well, that's the real essence again of understanding math. And if you are taking notes, paying attention to your teacher, then you'll be like, oh yes, I know exactly why we're doing this. And it's important because this stuff will come up again in the future, especially if you continue to take more math. And I hope that you do continue to take more math beyond Algebra 2, because math is so cool. Trust me, you'll love taking more advanced math, especially calculus and beyond. Okay, so if you enjoyed this video some way, found it helpful, okay, please consider smashing that like button. That would be helpful to me. And if you're new to my YouTube channel, please consider subscribing. I've been on YouTube for a good 10 years at the time of this video, and I have hundreds and hundreds of videos on my channel there for you, from basic to advanced. Obviously, I love teaching math, but if you want my best work, follow those links in the description of this video. But with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time, and have a great day.